way up to this. He wants to get rid of all this old pipe and put it in his sleeve. So what have we got when we're done? What is Kenny's inherit after this project's done? When we put all the new curve on it and everything. We've got an existing 8, we've got an existing 8, an existing 8, down to the hydrant. We've eliminated everything here. Down the road, this 6 may become an 8. So all they got to do is shut this valve, and shut this valve, put the new 8 on here, take this reducer on, go with an 8. They can use this hydrant to flush the next main. Not super important design criteria, but when you're designing this stuff, it's just one of those things you keep in the back of your mind. How am I going to screw the next guy? What can I put here? Can I put a valve and this thing better for the next guy beyond me? Because you may be the next guy. But that's happened to me. I did one street, and then 10 years later, we did the next part, and I was like, oh, I got my valve in there. This is easy. So that's what we want to do there. And rather than just drawing it for you and have you draft it, if you understand these concepts, I never have to do this. I could send you out to Kenny, and you'll say, no, you got it. But because it's every intersection of all the water mains basically is like this. Do I have my restraint requirements met? What sizes do I have? Is there a way I can maximize my hydrants? Is there a way I can put my hydrants where I'm getting the air out of the line? Is there a way I can put my hydrants where I'm getting grit out of my line? Do I have enough hydrants there to meet Penn State standards? Do I have enough hydrants there to flush it? How am I going to back T-test it? How am I going to keep this guy in service? There's all this stuff that goes on just on the water. Then you move on to the sewer.
We still had to take these steps as far as the dimensional requirements of friction on the soil if it was a mechanical joint instead of a push-on.
If the existing were mechanical joints, yes, you wouldn't have to, but you would have no way of knowing. This pipe could have been put in 10 years ago, or 200 years ago, or 150 years ago.
So we're
always assuming there's no restraint.
Okay.
If there is restraint, then you just spend some money for nothing. But there's no way you could know that. And most likely, this came up here and dead-ended, and it may be restraint. Or at one time, maybe there was a thrust block here. And years ago, they didn't do restraint. They did thrust blocks. What happens if you take that thrust block off? You've got a little time bomb going on in your underground, which is not a huge deal, but all of a sudden you get this water main break. Nobody can figure out what happened because it's the middle of summer. Well, the thrust block shifted, which I've seen that happen. Somebody did some wrecks, just got hurt. Same deal. Now, when you hear the term line stop, and you'll see these on the fast lane, where a line stop, that's a riser stop. But it's a bladder that goes into the main on bigger mains. And you have to treat a line stop just like we thought that dead end or on Pat did a job for him. He had to have, because he was doing 24 and 30 inch, Pat had to have like a huge amount of distance of existing. He had to put that line stop like the next block. So what he did in Hammond on a big scale is exactly what you were doing here on a 6-inch smaller scale. But you're using an easy valve because they don't make easy valves in big stuff. But what he did on the big pipe is the same thing we're doing here, just bigger scale. So the big expensive jobs and the little jobs, they get the same consideration. And when it's all done, you're like, you're good for the future. You're good for the next guy having to shut it down. You got a hydrant that's going good. You got a plate now to flush. You can shut this main, shut this main, shut this main. You've got a place to feed it for flushing or feed it for pressure testing. You're good to go. So, long-winded answer, but that's what we're doing here. I changed this detail here, whatever you say, where we're going to come down a distance from the proposed 12 inches. We need to make all proposed thicker. Just maybe a yellow line, probably yellow. Come down here, show that easy valve, call easy valve, 6-inch easy valve, and you need to put a dimension. Probably from the end of your sleeve, wherever your sleeve is, you've got to have a dimension from the sleeve. The sleeve is where you're going to be cut. So the nailing factor starts at about the sleeve. And then usually there's a little bit sticking out. Because why would they want to dig up more pipe? So you can assume from the sleeve, if you set 30 feet from that sleeve and left a dimension there, then he knows that, well, I need to be, he may put it 50 feet down. which I really wouldn't care. Town guy may say lines at 50, not 30, but, okay?
So should I start from the hydrant and work my way back to
I would start at the hydrant, because the hydrant, and that's very good, because the hydrant you're not moving. Normally, on a job where you didn't have a hydrant that you were connecting into, you could put that hydrant wherever you want. But yes, what you're doing there is start at the hydrant, come off of the hydrant to where that existing 6 inches, put an 8x8 T,
then the reducer.
and then you're going to have an 8x8 T where the hydrant's at. Then you're going to come up with a line, which will be some piece of pipe, and then you're going to put a T here, and then an 8-inch valve, and then that's going to be an 8x12 reducer. This is your new line. Okay, so the new pipe.
So in order to get this dimension, I would have to come this way off of the hydrant. So I got my T, reducer, and then the sleeve. And then from the sleeve down to the valve, that's the 28 feet.
And actually, that valve back up. I see what you're asking, but for the drawings, you don't really. You're drawing these things at a big scale, so you're going to probably, you're measuring on your drawing is what I'm getting to. You may throw it at 40 feet, but as long as you tell the contractor how far away from the sleeve, then that's good. But here's what you're proposing. We'll do 12. We'll have that 12x8 reducer. And we'll come to 8-inch valve. We got an 8-inch RW valve. This will be an 8x8 T. And we'll come to an 8x6 T. And that'll be to the hydrant. That hydrant is existing. So, and this will come through here. And then we'll have an 8x6 reducer to a 6 sleeve. Okay? And then this here will come 8-inch with an 8-inch sleeve. And that will come to so really your guy is going to build this. Okay? So with a 12x8, and then actually we got a valve down here shown in yellow, so it just kind of sticks out, just kind of in the middle of that existing. Well, I'm showing it dashed, only because for years we always used dash, then they decided to use the W line, which either way, I still prefer the dash. But the important criteria is from 28 feet. The 28 feet here, I would use 30. Just 28 from the 28, 30. Contractors like to take a multiple of 5. We're going to need a dimension like this, saying 30 foot minimum. What you're saying by this detail is when you're going to build this, and you're going to use this existing hydrant, you're going to put this easy valve in here, it needs to be 30 foot away from what you're going to put in up here. Where's it going to be? Well, you shall be. So it kind of leaves the contractor some wiggle room of how he wants to do this, but ultimately, you're going to have a valve 30 feet away from what he's going to put in over here. Okay? So, valve shut that, and shut that valve here, that existing valve. If we didn't have this valve here, we couldn't do this. We didn't have these valves here, we couldn't do this. We probably would have to stop. When I saw that valve yesterday, which I didn't know was in there,
So I thought it was pretty long, right?
yeah, it's basically it's a T that's split in half, like a sleeve, and they put it over the main, and it looks like a T that would be on the side to a hydrant, but it's turned up, and it's just it's just a big rubber, like a big eraser that they shove down into the pipe, and it blocks it. Yeah, so